Okay, this is property number 5. Is if you apply row operations or column operations, the value of the determinant remain unchanged. For example, let's do in this example. Compute this determinant is 2 times 5 is 10 minus 4 times 3 is 12. The answer is negative 2, no? Now, suppose I apply some row operation. Suppose this row operation. Multiply by 2, factor 2, row 1, plus row 2, storage, and row 2. And we change this determinant like that. Look, let me show you. 2 times 2 is 4. And 4 plus 4 is 8. And store in the row 2. And the row 1 stays the same. And now likewise, 2 times 3 is 6. 6 plus 5 is 11. And when you compute this, determinant is 2 times 11 is 22. 8 times 3 is 24. The answer is negative. Wow, amazing. It's the same value. Okay, and likewise, we can do that using column operation. Okay, in matrix never we have column operation, only row. In matrix we have only row operations, but in determinant allow row operation and column operation. Suppose you multiply by 3 column 1 plus column 2 are stored in the column 2. So for example, the column 1 stays the same, but the column 2 no, change new value is like a 3 times 1 is 6, and 6 plus 3 is 9, and 3 times 4 is 12, and 12 plus 5 is 17. Okay, and now multiplication, 17 times 2 is 34, minus 9 times 4 is 36, and the answer is negative 2. So it stays the same, negative 2, negative 2, and negative 2 when you are doing row or column operations. Okay. Okay, let's do some example. The example 1 is this determinant is given. So you don't know who is X, Y, Z, U, V, W, no, you don't know. But this is equal 4, this is a given. I need to find this new determinant is similar to this, but not exactly the same. Well, you can see now, wow, look at that. What is the difference? The difference is that the row 3 and the row 1 is interchanging. Look, yeah, I know when the situation happens, the value for the determinant is exactly the same as this, but the opposite sign is -4. Okay? Example 2. Suppose that we have this determinant. If this determinant is given X, Y, Z, U, V, W, 1, 2, 3 is equal 4. It's the same. But you need to compute now a new determinant is formed by X, Y, Z, U, V, W, 2, 4, 6. Wow. The order is the same. Nothing interchange. But this is duplicate, no? Is 1 times 2 is 2, 2 times 2 is 4, 2 times 3 is 6. You apply the property number 4 can say that when you multiply any row or any column by one factor, in this case the factor is 2, the value of the determinant is also multiplied by 2. The answer is 4 times 2 is 8. Okay, let me see example 3. Again, if this determinant is given, it's the same. Compute this determinant. This looks like more complicated, but no, it's not complicated. Look, let me show you. You can see here, okay, 2 is a common factor. And apply the property number 4 the same. When you multiply one row or one column by one factor, you multiply the entire value for the determinant by the same factor. It's equivalent to say, como factor out these two. 1, 2, 3, x minus 3, y minus 6, z minus 9, and ubw. Okay. Now, I don't like this negative 3, negative 6, and negative 9, so I apply a row operation. For example, I propose you multiply by 3, look, so you multiply by 3, the row 1, and you add it with the row 2, and you storage in row 2. Okay, let's do it, this 2, don't forget this 2. Okay, row 1 stays the same, 1, 2, 3. Row 3 stays the same, ubw. Okay, now row 2, no, row 2 change. When you multiply, 3 times 1 is 3, plus 3 is 0. It's cancelled out that part is x. 3 times 2 is 6, minus 6 is 0, why? And 3 times 3 is 9, minus 9 is 0, is z. Now this is similar to this, but the only thing you should do is interchange. Interchange this, and this. And remember, when you interchange, you change the sign. When you interchange, you change the sign. So say this is the answer for this is positive 4. And positive 4 times 2 is positive 8. And this is the final answer. Easy. Okay, this is the last example. Suppose that you apply, I want to eliminate negative 1, negative 2, and negative 3. For the idea is you take the row 3, multiplication by 1, invisible 1. Take the same 1 times 1, 1 times 2, 1 times 3 plus row 2, and store this new information in the row 2. So when you are doing this operation, for example, row 1 stays the same, row 3 stays the same. Now the only row we change is row 2. So when you add in this and this is cancelled, this is cancelled, and this is cancelled, and stay 3u, 3v, and 3w. Okay, we apply the property here, number 5. Now you can see, wow, 3 is a common factor, factor out. Property number 4. X plus 3, y plus 6, z plus 9, ubw, 1, 2, 3. Okay, finally, you apply another row operation because I want to remove this multiplication by 3, minus 3, opposite sign, minus 3 times row 3 plus row 1, storage in row 1. So when you multiply, you get, don't forget this 3, okay, you apply a row operation, multiplication by negative 3 times 1 is negative 3, plus 3 is 0, cancel out this, negative 3 times 2 is negative 6, plus 6 is 0, and negative 3 times 3 is negative 9, and plus 9 is 0. Stay then x, y, z, ubw, x, y, z. Okay, and this look like similar to this, but you interchange. Wait a second. This is wrong. This is 1, 2, 3. Sorry. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. What should I do? Well, this row is the same, but you interchange. You interchange this and this. And when you interchange this and this, the value for this new determinant is completely opposite side to this. So this is no negative 4, a positive 4, and positive 4 times 3 is 12. The answer is 12. Okay, nice.